So coming to the second problem now, you can see the problem is a little bit lengthier, but the solution will be very smaller. See, the question states that you need to determine the dielectric flux between two parallel flat metal plates, each with a square side of 35 centimeters with an air gap of between them. The potential difference being 3000 volts. So here the question states that you need to determine dielectric flux, which is nothing but Q, between the two parallel plate capacitors, each with a square side. So surface area will be 35 into 35 centimeters, right? Separated by the difference is 1.5 millimeters. The potential difference being V. So these two will give you capacitance, C into V will give you charge, which is equal to flux. And next, a sheet of insulating material of 1.5 mm thick is inserted between the plates. Entire thickness of 1.55 mm is now some insulating material. So if you insert this material, the voltage now is 7000 here. It is 7440 volts. What is the relative permittivity of the material? The charge now is 32 microcoulomb. Okay. So now what is the answer for this one? We take it as 7440. So first of all, we will try to solve this particular problem. Okay. Now, if you see what is the area, it is 35 into 35 centimeter square, which is 35 into 35 into 10 to the power of minus 4 meter square. And the separation is 1.5 millimeter, which is nothing but 1.5 into 10 to the power of minus 3 meters. And the medium is air, so see it is mentioned as area, right? So from this thing, what you will get, C is equal to epsilon naught epsilon r A by D, which is nothing but 8.85 into 10 to the power of minus 12 into 1 into A is 35 into 35 into 10 to the power of minus 4 by 1.5 into 10 to the power of minus 3. See, now let's calculate this capacitance. It is 8.85 into 35 into 35 divided by 5. It is 722.75 picofarad. Okay. Now, he has already mentioned that the V is equal to 3000 volts, and so automatically Q will become C into V. It is 722.75 into 3000 into 10 to the power of minus 12. Right. So what you will get? You will get 2.168 into 10 to the power of minus 6. So it is 2.168 microcoulombs. So now my charge is 2.168 microcoulombs. This is for the first case. So the flux is also Q, which is nothing but 2.168 microcoulombs. Now coming to the second problem, I'll take this. Now a sheet of insulating material is inserted between the plates. See, in the plates earlier were 1.5 mm thickness, separation. Now this entire medium 1.5 mm, he is saying very clearly, it is not a combination of air and this material. Complete gap is filled with insulating material. This makes our problem a little bit easier, right? Only one medium present now. So what he is saying, V is equal to 7440, and the charge is now C is equal to 32 microcoulombs. Separation we already know, area of cross section also we know, it was 35 into 35 into 10 to the power of minus 4. So what he wants? Permittivity of the material. So we will employ the same formula, Q is equal to CV, okay, where C is epsilon naught epsilon R A by D into V. This is 32 into 10 to the power of minus 6. Epsilon naught is 8.85 into 10 to the power of minus 12. Epsilon R is, which we need to find out. This is 35 into 35 into 10 to the power of minus 4. V is 7440 by separation is 1.5 into 10 to the power of minus 3. Right. So what is epsilon R? If you calculate it, we will get 59.88. It seems. So 5.988. So which is approximately equal to 6. So dielectric constant is 6 in this case. Okay. So this is what the problem is required. What is required? Relative permittivity of the material, and that is equal to here 6. Okay. Now we will move on to the next problem now. See the capacitance of a parallel plate capacitor with two parallel plate metal sheets, each of 100 square centimeters. So this is area because it is already given as square centimeter. A is equal to 100 centimeters square, which means it is 100 into 10 to the power of minus 4 meters square. It is separated by dielectric medium. It is D is equal to 2 mm. This is 2 into 10 to the power of minus 3 meters. This is capacitance, right? Pico means 10 to the power of minus 12. And potential difference of 20 kV. This is V. All the value have been given. What he needs to find out? Relative permittivity he needs to find out. Epsilon R. Dielectric flux psi, which is nothing but Q. Potential gradient in kV per second. What is potential gradient, guys? It is V by D. This is electric flux density, which is nothing but D Q by A. Or you can write epsilon naught epsilon R into E. Anything is okay. So I will compute each of these things now. Okay. So the first thing is you will write down separate area. It is 100 square centimeters. It is 100 into 10 to the power of minus 4 meters. Thickness is D is equal to 2 into 10 to the power of minus 3. V is equal to 20 into 10 to the power of 3. This is capacitance. Right, I am not mentioning any units here. Okay. So first of all, relative permittivity of the dielectric material. So what is the best formula? C is equal to epsilon naught epsilon R A by D. Right. So if I substitute it, this is 200 into 10 to the power of minus 12 is equal to epsilon naught is 8.85 10 to the power of minus 12 into epsilon R. I don't know. A is 100 into 10 to the power of minus 4 by D is 2 into 10 to the power of minus 3. Right. So what is epsilon R from here? If I calculate, it is 4.5. It is 4.5. So first problem is solved. Next is total dielectric flux. Psi, you know it is already equal to Q, which is nothing but CV. C is already there with you, 200 pico, 10 to the power of minus 12. Right, into V is also there, 20 into 10 to the power of 3. This is 4000. So 4 into 10 to the power of minus 6. 4 microcoulombs. Right. Now the next one is potential gradient. Potential gradient is V by D. V is already there with you. 20 into 10 to the power of 3 by separation is 2 into 10 to the power of minus 3. So what you will get? 10 into 10 to the power of 6 volts per meter. But he wants in kV per centimeter, right? So I will convert this one into this is 10 into 10 to the power of 6. If I convert volts into kV it is 10 to the power of minus 3. This is 10 to the power of 2. So it is, we'll get somewhere around 1 minute. Right. Now, next is electric flux density, which is nothing but Q by A. Q already I do have 400 into 10 minus 6. Area also I do have 100 into 10 to the power of minus 4. So what I'll be getting here, 4 by 100 into 10 to the power of minus 2. So it is 4 into 10 to the power of minus 4. It is 400 micro coulombs per meter square. I can write it as micro, right? 400 microcoulombs per meter square. Okay, so this is capacitance, flux, field density, and flux density from the same problem. Okay, so this is the way how we calculate the things. I hope you practice the other problems in the tutorial. Thank you.